Hello everyone, welcome to the Cloud Data Architecture series sessions. Today we'll look at one of the topics which is gaining a lot of popularity these days. Lakehouse is something which is trending in 2022. We'll look at some of the factors. Why do we need a lakehouse, and what are the challenges with the older architectures that we have been using. We'll look at the challenges of building a data lake, or what are the issues with data lake, or the issues with just having a warehouse, or even the combination of a data lake and a data warehouse. And I will first look at those challenges, and then we'll get on to lakehouse. What is a lakehouse, and how it can help, and what are the enterprises right in today's time looking at as part of building these lake houses. Okay, so let's get started. So data warehouses, right? I think most of you would be aware of a warehouse. Some of you would have already worked on projects where you had built a warehouses. Some time back, right? Like maybe the late 90s or the early 2000s, right? A lot of data ecosystems were using warehouses, right? And the main use case that time was to generate BI reports out of the system, or to generate some management reports, or to ask some questions related to things that have happened. The reports were mainly related to what things happened, right? It was more of getting answers to what were the things happened and why did those happen, right? And the main uh, type of data was structured data. There was not much of unstructured data. So those were the times when there were multiple source systems like databases and flat files or CSV files. Okay, more or less these were the only two source systems. There was not any social media feeds as such, and they would send the data from OLTP systems. We would ETL them. We would use tools like Informatica Data Stage, or maybe the open source like Pentagon Talent to do the required transformations. And we used to do ETL, right? It was not even ELT. So extract, transform, and load, and finally load it into the warehouses. And the warehouses were built in either Teradata or Netezza, or even if it would have been Oracle or DB2 systems. But this was all about loading the structured data. So the use case, right, that this kind of an architecture was targeted towards was only the BI workloads, right? Generating any of the management reports or any of the structured reports that user wanted to see. Now these systems, the problem with these systems was, these were pretty costly, right? Because we were using appliances like Teradata, Netezza. This has to be purchased at appliances along with the along with the software. It would come along with the hardware as well, right? So it was high cost. Um, the other challenge was, as I said, right, it was only structured data. So though that time it was mainly having structured data, but when the social media feed started coming in, right, like with Twitter or Facebook, uh, and with a lot of people generating a lot of images and videos and audios with smartphones, right, then it became a problem to store this data and to analyze it, right? So it would not give the complete data stories. So it would only cater towards your warehouse, and that is when people started building the data lakes, because there was a gap of not having the complete data with your warehouse. And that is how data lake came into picture, which we'll see in the next slide. Okay. um, some of the other challenges with these warehouses were, It was just limited to certain personas. Today, right, we talk about data engineers, analysts, data scientists, ML engineers, right? So warehouse was only for your data analyst who can query the data, or the business analyst who can query the data, maybe for your visualization engineers who would play around only with the structured data and creates the report, right? So it did not cater to your AI ML workloads, right? So these were the important limitations of a warehouse. Also, there was not a lot of support for streaming data. If at all there would be any streaming data or real time data, the systems were not matured enough to be able to load this data or ingest this data for streaming data. And that is why, right, in the late 2000s, somewhere around maybe 2008 2010 onwards, some of the organizations started building the data lakes, right? Now data lakes were revolutionary that time, because it gave the enterprises a lot of flexibility from storing the data, and not just storing but also to have different kind of workloads on this. So you could store your unstructured data, semi-structured data coming from multiple feeds, so social media feeds such as Twitter and Facebook, and multiple other social media feeds. Since there was no limitation of having just structured data, uh, people could uh, ingest any kind of data using any of the processes. Like it could be an ETL process, or it could be just an ingestion process. So data could be easily stored in these. Since unstructured data was stored in these data lakes, it catered to different workloads, like AI ML workloads. So no more you could only use your persisted data in your data ecosystem only for your BI purposes. So all the AI ML workloads, all those use cases could now be implemented using data lakes. Uh, so people started using these data lakes. Also, Hadoop was the main solution for implementing these data lakes. HDFS was widely being used, and since it came with commodity hardware, right? It addressed the concerns related to cost as well, right? So there was a cheaper storage, right? There was a more flexibility towards storing a lot of unstructured and semi-structured data, right? And it also came in with a lot of parallel processing, parallel computing, right? And you could easily scale this, maybe not quickly as what we do in today's world with cloud, but there was flexibility to scale the storage as well. But there were certain challenges with data lakes as well, right? With any system, always there would be pros and cons. And so slowly people started realizing the challenges with data lakes. The most important being, right, these data lakes were being converted into data swamps, wherein data was just being dumped, but it was not being utilized, or no information was being extracted out of this data. So data just being ingested is of no use until unless we really go and use this data, right? Insight generation, or getting some information, or using it for some predictions, right? That is the main use of this data. But with data lake, there were these challenges that it was just being used for archiving the data sometimes. Now, the main problem being was there was no data discoverability, right? People were not aware of what kind of data is being stored. So to utilize some data, we should know what kind of data is stored, and then we can think about how to utilize that. So there was no metadata properly stored. It was just file being dumped. So it was becoming very difficult to get some meaning out of this data. Also, data lake was more about getting the raw data as is, not doing the required transformation immediately. To do those transformation only if it is required, which again raised challenges related to the data maturity. And data maturity, then there were multiple factors, right? It was not just one dimension, but multiple things, right? The data quality was not good enough. Maybe the data was not complete. Data accuracy was always a concern. So there were multiple such issues with data lake. So when data lake came into picture, it was mainly to address the issues or the challenges that we face with warehousing, right? Where warehouse had a limitation of having or keeping or storing the unstructured data, the cost related issues, right? While data lake solved most of these challenges, uh, it resulted into these other challenges, right? Also, performance was a problem because since this was unstructured data, there was no structure to it. Getting writing queries and getting this data out was difficult. It is not easy to get data or query data out from a system which does not have a tabular format. It won't support any, any of those database related performance optimizations like partitioning, indexing, and all. And finally, the most important one, where a lot of architects also had a concern, was there was no ACID support. So you cannot really update something in data lake. So if you want to update something which is in HDFS and you have built a Hive table, you cannot really direct go and update something, right? You will have to take a copy of that, then make the changes, then bring that older table again, rename it as a new. So it was not a straightforward method. So those who have worked on this, those who have created a system, they would understand this. There was no time travel. Again, time travel is though a new feature. That time people didn't realize that this is one of the limitations. But yeah, I mean, if you updated something, you cannot actually go back in time and see what was the state of that data earlier. I won't say this was a major challenge, but now with a lot of new things coming up, we can think about, this is still a challenge in the data lake if we implement one today. Okay. Uh, Now this was something, I started seeing from 2010 2011 onwards, right? A lot of organizations started moving to data lake Hadoop, and when we started facing these challenges, uh, we also started discussing about a new architecture which would have a data lake and a where data warehouse, right? So far we saw what warehouse did, then we started building our data lakes, um, and then sometime 2-3 years back, I've seen people implementing a data lake plus data warehouse. Sometimes it was also called as a lake house, but now it has a completely different meaning. So let's call it a data lake plus a data warehouse architecture. Now why this architecture, right? Because right, everyone thought that this would bring in the advantages of data lake as well as a warehouse. We could get something which is like best of both the worlds. um, and we could have better performance, lesser cost, all the good things that warehouse could bring in, all the best practices from data lake system. And that is where there were architectures being built using this kind of a architecture, right? Having a both data lake as well as a warehouse. So you would first land the data into your data lake. Okay, all the data from your source systems would get into your data lake, and then this data would move from your data lake to the warehouse. Now it could be, right, only just the hot data, most frequently used data, right? There would be multiple combinations. And how it would help is all your BI kind of a workloads would get extracted from your warehouse. All your while all your AI and ML would come from the data lake. Okay, and it looked really promising because you have two separate systems. You For the personas who are trying to access them, and you would get what you are looking for, right, from performance as well as the scalability, and the workload separation as well. But then again, a lot of challenges are currently being highlighted of this system in last 6 months to 1 year, when we have started talking about true lake houses. Okay, and I'll come to the true lake house part in my next slide. But before that, why people started talking about that, right? Because of the limitations of this kind of architecture as well, right? While the data lake and data warehouse address a lot of challenges of the systems which individually had these, there were other challenges, right? As we saw with data lake also, while it addresses one challenge, uh, it um, uh, it gives more challenges in some other areas, right? And with data lake and data warehouse, what were the new challenges, right? These were related to the architecture itself, because it's a bit complex architecture, right? There are multiple layers. You have a data lake and you have a warehouse, so it's not a single source of truth, right? The same data would reside in your data lake and the same data would reside in your data warehouse. It may happen, right? Like 100% data is in data lake, but out of that just 30% is on warehouse, because you would be moving just the data which the BI workloads would need, or the hot data, right? Or the frequently queried data. All right. But yes, but this resulted in this architecture being a complex one. It's not a simple architecture, right? Because you have to maintain two copies of data. It should be in sync all the time. And the moment something like this comes into picture, right, where you have to sync the data, keep two layers in parallel, a lot of challenges come up, right? If something goes down, then how do you ensure that uh, after the failover and after the restart, the data gets copied back and it is in sync, right? If someone is querying the data at any point of time, would they be able to see the exact same copy of data or the same version of data? So all these challenges or the issues or limitations would come up with these kind of architecture. Okay. um, and the next one was, you need additional compute, right? Because you have data lake and you have a warehouse, you need to move your data from your data lake to warehouse. Now this results in additional compute. There would be some ETL layer or ELT layer, right? Wherein you will have to first move the data from data lake to your warehouse and then do the required transformation. So this additional compute was required, which again resulted in additional cost, right? So eventually we were trying to reduce the cost of the storage, right, with data lake and using commodity hardware. But now with this kind of architecture, we were adding the cost. Operational overhead was more, right, as I mentioned earlier, keeping things in sync and maintaining two copies of data. There would be obviously more operational overhead, which we'll have to cater to. The biggest problem with warehouses was, and which I think I missed in the previous slide, it's a proprietary DWS storage. You cannot really go and query the data which is in backend, right? You have to, if you want to access any data which is in warehouse, you have to go through that warehousing layer. So you have to use the warehouse's compute to access that data. Now this issue was with the data warehousing systems also, and this issue would be there with data lake plus data warehouse systems also. So whatever issues were there at the individual level, right, some of them were still there in this kind of architecture also. So having a proprietary DWH storage still resulted in vendor lock-in kind of a thing, where people cannot move out of that warehouse easily, right? And the last one right here, though it supports, it helps in your workload isolation. You have your BI workloads on warehouse, AI on your data lake, but then you have two different storages for different personas, right? The data analyst would be accessing warehouse, while the ML engineers would be accessing data lake. And if at all they need some data from the other storage, again they would have to go through the cycle. They need that access and all those things. So not having the single source of truth, having multiple versions of data, having different storages for different personas, all this were adding to the um, making the architecture more complex. Wherein today's world we are looking for a more simple kind of architecture, right? That is where people were facing a lot of challenges, and this gave rise to the true lakehouse architecture, right? So this is where people started talking about having a true lake house, and a lot of discussions have been happening around this on this front. So I'll move to that part now. Let's talk more about having a true lake house and what actually it is and how does it solve the problem. Okay, so a lot of discussions have been happening in this area, and I've been reading through a lot of blogs. I've watched a lot of videos, and there are multiple vendors who are talking about this. So in this lecture, right, I won't talk a lot about the products or the vendors who are doing that, but let's talk more about the need of a lake house and what actually is the enterprises looking for, and how would a lake house help, right? Now, before we actually get onto the lake house, let's try to understand what do enterprises need at this at this time, right? What are people looking at, right? So because of the complexity of the data ecosystem, and there are multiple moving components, there are multiple um, services which are available, and already a lot of architectures have become really complicated. So people are looking at a simple architecture. Okay, simplicity is what most of the customers are these days looking at, so that we can have a simple architecture which can easily scale and which is easy to manage, and it can be used to onboard on new use cases, right, to implement the new any future use cases. And from that perspective, right, things have started moving into that direction where we get a simpler architecture. Okay. Second is people are looking for still a cheaper storage, right? What data lake gave was a cheaper storage, but with warehouses, right, uh, again this would cost a lot, right, with the proprietary data warehouse systems. Though there would be warehouses which are still using the cloud storage and all, but to access that you would need that warehouses compute. Okay. Which would still make it expensive system, though the storage is cheaper, but the compute was not that cheap, right? So it goes hand in hand. It should not be just cheaper storage, right? Even to access, even if the storage is cheaper, to access that you should not be spending a bomb on the compute to access the storage. Okay. Second is people are looking for a faster compute, right? A compute layer which would be more faster, right, and faster on data lake itself, not on a warehouse. We all know, right, if we have the data in that format, in the tabular one, then it would be much faster because of the various optimization that warehouse brings in. So now people are looking at whether those kind of a performance optimizations can be brought at the data lake level, right? Can we have a DW scale performance on a data lake, right? That is what everyone is now looking at. uh, Another important point is the separate storage and compute. Now this has become one of the fundamental building blocks. No one wants to use a layer where your storage and compute are tightly coupled, though it has its own advantages, right? You get the data locality advantage and all, but nowadays the compute has become much powerful that you don't really worry about the locality part, which became very popular during the Hadoop days, right? Since you had the data node, you had the compute and the storage on the same node, the data retrieval was much faster. But nowadays it's more about having a separate storage and compute, so that the scaling would be separate. So tomorrow, if your storage demand increases, you don't need to spend a lot on increasing the compute also. You just have to increase your storage, right? And vice versa, right? It should be scalable separately. That's the most important one. Uh, Third is enterprises are looking at open formats where data can be stored and accessed independently without getting locked in any proprietary tool, right? Uh, they want a system where data can be stored on a cloud storage, which is really cheap, okay, but it should can be accessed. It should we should be able to access it by using any compute of our choice, right? Which is also cheaper. It should not happen that I'm using a storage, the storage is cheaper, but to access that, right, I need to have some compute along with it and spend a lot of money on that. So people are looking at uh, a cheaper storage where there is no lock-in, with open data formats which can be directly accessed. You don't need to go through a vendor or a warehouse to access that data. It should be as easy as going and querying that data using any of the compute engine available. It can be an open source compute engine also, like Presto or something, right? um the this new modern architecture should support a quick data ingestion, and it should have an easy access. and a simple access, right? Data ingestion should be straightforward. It should be easy. It should get connected easily to, all other systems. The connector should be easily available, or it can be, connected using the known frameworks like Spark and all, right? The next point is this modern ecosystem should support all personas, right? And all workloads like AI to BI, right? You might be a data engineer, you might be a data scientist, you might be a data analyst. Whoever you are, you should be able to get your answers from this single storage. Okay, this data ecosystem should have a single storage. It should be a single source of truth. Any persona, any type of user should be able to get his data from this single storage. They should not be thinking whether should I go to a warehouse and get that data, or should I go to a data lake and get that data, right? It should be a single platform, open for all the users. Our data lineage is something very very important, and not a lot of things have happened in the cloud data services world for that. But customers are looking for an end-to-end lineage, wherein they would be easily able to uh, identify the data journey, not just at a file level or table level, but at an attribute level, right? If there is a particular attribute in a table where you are calculating some um, uh, say you are calculating balances for a particular account, you should be able to track it right from the source system, which source sent it, from which attributes are impacting this, or from which attributes it's being derived, what are the transformation, right? And end-to-end lineage is what enterprises are looking at, along with the data discoverability, of course, right? There should be metadata which can help in discovering the data, and there should be a data lineage to track how the data is being uh, migrated from, or how the data is flowing from the source to target. Okay, and lastly, there should be easy updates, right? It should not be like a data lake where you cannot update the data because it's immutable. Enterprises are looking at cheaper storage with open formats which can support ACID transactions, right? And where they data can be easily updated, and at the same time, it can support features like the time travel, where data can be easily recovered without actually taking the backups and restoring it and all those things, right? Where an admin is required. The developers itself should be able to immediately um, go back in time and retrieve that data easily. Now some of the systems do support that, right? Because see, all these points, you these might sound familiar to you, because these are available at some of the tools like Snowflake provides a lot of things, Databricks provides a lot of things, AWS, Azure, right? Their offerings provide a lot of things. Okay. Yeah, but this is all combination of these. Like some of them would provide some of these things, but not all of these things. So enterprise today are looking at a modern ecosystem where all these things can be provided. Okay, or maybe it can be done by using all these systems or some of these tools and platforms. But this is the current need of the enterprises. Okay, now let's look at Lakehouse. So is the Lakehouse need of the hour, right? And can Lakehouse answer all these queries, or can it support all these requirements, right? We saw a lot of demands in our previous slide, what customers are looking for. So can Lakehouse support all of these? Now, maybe not all, but most of them, right? Is the lake house answer for this? So before that, what's a lake house, right? So lake house is nothing but it's still a data lake. Okay, it's still a data lake, but there is no separate warehouse. Look at the third architecture that we looked at, right? The first one was warehouse, the second was data lake, the third was data lake plus warehouse. So lake house is very similar to a data lake. Okay, the second one, but it should also have the benefits of a warehouse, right? uh, Now warehouse gives you a better performance, right? It gives you a better performance. It gives you those ability to update the data. It supports ACID transactions, right? So Lakehouse would be able to do all these things. Okay, so primary lakehouse is a data lake, okay, where you can store all your data, structured data, unstructured data, semi-structured data, right? It can have all kinds of data, all the features of a data lake, plus it should be able to give you performance that of a warehouse. And so it would be the, in true sense, it would be the best of both the worlds, right? So you don't have to build a separate warehouse here. You still have your data in your data lake, okay, but when you query the data, you would get a better performance which is at par to a warehouse. Okay, it would act as a single source of truth, since there won't be any warehousing layer, right? There would be only and only one single data lake layer from where everyone would go and access the data, right? So these are all whatever the demands of customer were, Lakehouse is going to answer all of them. It's going to be the solution. It's going to be the solution for all those issues or concerns which the customer has been raising, right? uh, Lake houses would be built on the cheap cloud storages, right? Because one of the important concern is to keep your storage still cheaper, right? Because data is increasing, right? The storage demand is going to increase, right? So you want cheaper storages. You cannot afford to have expensive storages, right? So there should be cheaper storage, and at the same time it should be a open data formats, right? Open data format, so that anyone should be able to query that data, access that data. It should not be locked in some proprietary storages like the warehouses did. Okay, so that is where the open data formats come in. So lake houses, when you implement, it would be using open data formats like Apache Iceberg, or maybe Delta Lake, which has been open sourced by Databricks, or even Apache Hudi for that matter, right? Um, Now these can support the ACID transactions also, because that was again one of the important concerns. Data lake should support ACID and time travel support. So maybe our Iceberg or Delta Lake or Apache Hudi, right? These are the three main choices in today's times, where you can do the ACID and time travel also. And then since it's just a data lake, it's not a warehouse, you can have a compute engine of your choice, right? You can have your Spark jobs on top of it, right? But again, these compute engines should be good enough to give you the performance of a warehouse. And that is where now a lot of vendors, have started building a better compute engine that could work with an open data format and have it on cloud storage. Like Databricks has the DB SQL. They are doing a lot of things on these. They were the ones who coined the term Lakehouse, and a lot of things they have been doing. There are some other tools like there are some uh, um, other companies like Dreamio who are building things on the Apache Iceberg, and they have their own engine. Even if we try to use AWS EMR, we might be able to get these kind of things. AWS had been supporting Hudi. Now they've also announced the support for Iceberg as well. Now Iceberg might gain a lot of traction in coming times because of the open data format and its support for ACID, right? So all these things are being supported by Lakehouse. It would support any workloads, right, from BI to AI, right? Your BI would be also from data lake, because if your compute engine, it is performant enough to get the data, right? So BI to AI workloads would be supported, and it is for all the personas, right? You might be a data engineer, data analyst, data scientist, ML engineer, visualization engineer, tester, right? All of you would be able to get the data, right, out of this one single source of truth. You don't have to worry from where you have to take the data. Now this is the need of the hour. Lake houses, the current modern lake houses are capable of giving all these things, but at the same time, like as we always saw, right, one architecture would have a pros and there would be cons also. There might be few cons that might come up later. Maybe the performances are not that great, maybe not at par with the warehouse, but still if they are if it gives a slightly lesser than the warehouse, even that should be fine for the batch workloads and all. We still have to wait and see how they would perform with the real time systems. Data lineage is still an issue. whether they would be able to give that lineage. Again, Databricks is coming up with the Unity data, Unity catalog, where they would be able to give the lineage. They're also working on orchestration related things, where you get a lot of in-house orchestration within the ecosystem, rather than going to a third party tool like Airflow. So a lot of things are happening at the Lakehouse level, and it looks like this would be the answer to all the not all, but the most of the challenges that the current data architectures have. So definitely it would be worth to watch out for this space. And what are the initiatives happening in the data in the Lakehouse world for this, right? Now this is a very important topic. This is how they are supporting all this customer demands, right? The increasing customer demands. A lot of emphasis on having a cheaper storage, right? Because that is at the core of this. We don't want a cheaper storage with a powerful compute, where we have to spend a lot on the compute to access that, right? So storage should still be cheaper, and there should be faster compute on the data lake. um, Different people, different vendors are having a different strategies for that, right? It's more about um, how do you separate your cold data and your hot data, right? How do you put your hot data into SSDs, right? Where you will get faster data retrieval, bit at a bit more cost at the storage, but then 80% of the data is cold data, so you keep it on really really cheaper storages, right? So that you don't have to spend a lot on the cost, but at the same time, since you have your hot data on SSD, the retrieval is faster. Again, a lot of work is being done at the caching level, right? Where like Snowflake has been doing a lot at the caching level. So if that can be brought to the right Lakehouse architecture level, where any query which is executed first would check whether the data is available, whether it's just a metadata query, just the count check. It should be directly fetched without using the compute, right? The concepts related to um, having your block sizes when you store the data, right? What should be the block size, and how effectively, when a query is scanning these blocks, right? How do you ensure that you're hitting the right blocks only, or the minimum blocks only? So the concepts related to sorting the data, having the min and max values of these blocks, and then the query going and checking the min and max values, and based on that only hitting the required blocks, right? So all these are being being explored further. A lot of vendors, or a lot of products have been doing this very very effectively. The same concepts they are trying to build up on while building the data, this houses also, right? So these are all the levers to having a better compute, a faster compute, and the cheaper storage. Now while all this is being done, right, data governance is the one of the most important factor, wherein you have a proper metadata catalog to discover the data, to manage the lineage. So emphasis would be on overall data governance. How do you discover the data, how you tag the data, right? And then there would be a lot of focus on having open data formats, and that's where like Iceberg and Apache Hudi and Delta Lakes would be utilized. Getting the acid properties on the data lake, right? Though it's an immutable one, but how do you get the acid properties on data lake, right? How like different again, it is being done by writing the separate log files of your incremental data. If you have explored Apache Hudi or Iceberg, right, or even Delta Lake, would understand how they are maintaining that. So a lot of focus is on that area. In fact, AWS Lake Formation, I think the one of the latest feature is the governed tables, where you can also have features like acid data lake and time travel in it. So yeah, I mean, there are a lot of initiatives, and all the cloud providers and the vendors are putting focus efforts on this to make all these things better, to improve this. While we spoke about these things, uh, collaboration, right? It is again a very, very important factor which is being discussed a lot when we talk about different personas, right? We spoke about, and a data analyst should not be bothered whether he should get the data from a warehouse or lake. Now that we would have a single source of truth. Now, once this is there, it opens up a lot of possibilities related to collaboration, wherein the engineers and scientists are working together. They have the same notebooks to play around with. They have uh, the same compute cluster, which can be attached to a storage which is available to all of them. It is just, access control can be done at the persona level, at the role level, right? So all these things are currently, being explored a lot. The new additional features, right, like the data lineage and orchestration, which is still uh, new. It is still not available in some of the products, but these are also being explored. Once the data lineage part is, is also comes into picture, it will become a very it can become an end to end, uh, data ecosystem where you can build a complete solution on this lake house architecture, where you would get a cheaper storage, you will get a faster compute, you will get the power of, collaboration, you will get the performance of a warehouse, as well as you will also get the data lineage and the ease of, uh, ease of orchestration. I would say not the ease of integration, because you don't really would have to worry about integrating the data lake and the warehouse, but orchestrating your end to end data flow. So yeah, I mean, all exciting times. A lot of things are happening in all these areas. Do keep an eye on all these, initiatives. Have a look at the um, various sessions and webinars that are being organized on these, and based on that you can take a call on what kind of architecture you would want to implement, what are the tools that you would, would like to have. And there are multiple tools, right from Databricks, Dreamio, AWS, Azure, right? A lot of things are happening in this world, along with the uh, open formats like Iceberg and Delta Lakes, as well as Apache Hudi. And we can build a system based on the use cases and what why we are trying to do. So yeah, that's it for the day. I hope you have enjoyed this session. Maybe you can go back and look at all these sessions and read some of the white papers and see what is best for you. And if you have liked this lecture, maybe you can just follow me on Medium and Twitter. That's my handle. Uh, thanks for listening to me.